Okay, so the law of sines states that if we have any triangle, doesn't have to be a right triangle necessarily, but any triangle, ABC with sides little a, little b, and little c, that what we came up with a while ago is true, and it looks like this, that A over sine of angle A is equal to side B over sine of angle B. And we can do that with any of the sides. We can go B over sine of B is equal to little c over sine of C. And then, of course, A over sine of A would be equal to C over sine of C. And, of course, the condensed version, I guess, of that, I always learned it that A over sine of A equals B over sine of B equals C over sine of C. And then you just picked out whichever two that you wanted to use on this. That is the law of sines. How are we going to use it? What am I going to do with it? Well, let's go over and see. If I have an oblique triangle, once again, oblique means not right, triangle ABC, and let's say I know some of the parts of the triangle, like maybe side little a over here, excuse me, is 42.9. And that maybe angle A is 32.0. And that angle B is 81.8 degrees. Okay? Of course, this would be side little b, this would be side little c. And if I wanted to solve this triangle, well, the easiest thing to find is angle C, because I know the angles of a triangle add up to 180. So I can do that. I'll do it really fast here. 32 plus 81.8, and then subtract that from 180. 180 minus 113.8 gives me 66.2 degrees. So angle C is 66.2 degrees. Now remember, if I can avoid it, I'm not going to use something that I've calculated in order to find the missing parts. Try to always go back to what they give me. So, well, now we have to pick a side. Do we want to find side B or side C? And I'm going to say we're going to find side B first, okay? So I look at it, I know angle A and I know side A. So of course that tells me that's part of the thing that I'm going to use, that A over sine of A, or sine of A over little a, however you want to word it, is going to be equal to B over sine of B. Okay, so let's set that up. A, 42.9 over the sine of A, which is 32, is equal to B, we don't know that, over sine of B. And B is 81.8. Well, once you look at this, you can see hopefully a proportion. You just cross multiply, set things equal, and divide to solve. B times sine of 32, B sine 32 equals 42.9 times the sine of 81.8. And then to solve for B, we divide by sine 32. All right, so B will equal, and we're going to put this stuff here in the calculator, That's 42.9 times the sine of 32. I'm sorry, sine of 81.8. Better get this in degree mode. That's in radian mode. There we go. Now I can do it. 42.9 times the sine of 81.8 equals divided by the sine of 32 equals 80.1. Okay, so little b is 80.1 units. In a similar fashion now, we are going to have to use our 66.2 that we calculated. But, I mean, you're adding and subtracting, so that's not going to be a bad deal. And we're going to do, I'm going to go back to using the a because that's what he initially gave us that we know. So a over sine a, which is 42.9. And I may run out of room here. I'm going to write a little smaller, so I'll slide my paper up. Over sine of a, which is sine 32, equals c over sine of c, which is 66.2. Now, I'm not going to show my work on this when I'm running out of room, but anyway. So it's going to be 42.9 times the sine of 66 equals, and then I'm going to divide that by the sine of 32. And I get C, side C is 74.1. Anyway, that's how you use this to solve triangles. And of course, they're going to put together some word problems and things like that. I'm just mainly going to give you guys some triangles that you can solve in your for some work to do, probably about 8 or 10 of them, to give you some practice using the law of sines to solve the triangles. And that will come up in an assignment that matches this lesson, and then we'll move on. And there's some more stuff that we can do. We'll be learning about finding the area of a triangle in different ways than you've perhaps done, as well as there is a case where the law of sines does not work here. There's some ambiguity that comes in, and that gets a little frustrating, but I've got some stuff, hopefully, that'll clear that up for us whenever I get ready to cross that bridge. But that's it for today.